Hey there, hi. Hope you're doing great. Welcome to this learning space. I am Mitali, and in this video, we discuss a very fundamental and important concept of physics, that is motion. So brace up yourselves to deep dive into the world of motion with me. To start with, let me tell you that I have always been fond of NCERTs from the time I was in my school. They are very well researched and made by due consideration. So all my videos will be based on them. Motion is chapter 8 in class 9th textbook. You can consider the upcoming content on the screen as a gist or notes of the chapter in the book. I haven't changed it much so that all of you can always refer the book and understand it better. Also during the course, we shall discuss various activities and the in-text questions which are very important to clear your concepts. Here we start. For ease of understanding, I have divided the chapter into two modules. Module 1 will be related to understanding motion, various types of motions, and the terms related to it. Module 2 will cover graphical representation of motion and equations of motion. This video deals with Module 1, wherein we cover the major topics as per the NCERT. The sequence of the topics we'll cover in are: first we'll understand and define motion, then we will understand motion along a straight line, uniform and non-uniform motion, measuring the rate of motion, and finally uniform circular motion. Now before defining the term motion, let us all discuss a related term, that is rest. I know हम सब जानते हैं rest क्या होता है. We did not define the term, but still, if you have to give a definition to the term rest, then you can say that when the position of a body with respect to its surroundings does not change with time, the body is in rest. Like a mobile phone lying down, it is not moving, so it is in rest. When you are sleeping, your body is not moving, then you can say that your body is in rest. So if you understand the concept of rest, या फिर तुम्हें एक clarity है कि body rest में कब है, then it becomes very easy for you to understand what motion is, because motion as a term is quite opposite to what rest is. So if I define motion, I can say that when the position of an object changes with time, the object is in motion. Now look at these images. There are many incidences that happen around us. We can easily quote if a body is in motion or not by looking at the body. If you see a bird flying, or if you've ever seen fishes swimming in the ocean, if you see yourself walking or other person walking, if you see a car passing by, you know all of these objects are in motion because they change their position with time. They are not stagnant. They are moving. They are changing their position in time. Generally, we can tell if an object is in motion by viewing it, but there are situations where we infer motion through indirect evidences. Like, we know that the earth rotates around its own axis. We know it revolves around the sun, but we cannot see it through our eyes directly. But we can infer it. How do we infer it? We infer it by viewing the sunset, sunrise, the changes in season. There is one other such instance where you infer motion. It is when an object appearing stationary to one person and moving to other. A classic example of the same can be if you are sitting in a bus, your body is in rest and the bus is moving. But for a person viewing it from outside, sees the bus and your body both are moving, right? So these are certain instances where you know or you infer motion through indirect evidences. Now, when we talk about daily motion that we observe or we know, we can say that most motions are complex. They are not very easy to define or say. Not every motion can be along a straight line. The motion could be in a circular path, An object may be oscillating, it may be rotating, it may be revolving, it may be vibrating. It may have combination of more than one type of motion. So we can say that most motions are complex in nature. Now, to study further or discuss further or move further in motion, we need to understand a very basic concept, that is reference point or the origin, है ना? अब मैं अगर तुमसे पूछती हूँ कि तुम्हारा स्कूल तुम्हारे घर से कितना दूर है, या मैं पूछती हूँ कि रेलवे स्टेशन तुम्हारे घर से कितना दूर है, या इन जनरल मैं पूछती हूँ कि वेयर इज द एयरपोर्ट इन योर सिटी, and you say like 45 kilometers. How? Kahan se 45 kilometers? It can't be equidistant from every place in the city. There is always a starting point. There is always a origin. There is always a reference point from where you define कि distance कितना है. So, to describe the position of an object, we need to specify a reference point, a origin point, right? So, reference point or origin point is from where you define the position of an object, right? As I had mentioned earlier, that we will also be discussing on various activities and the in-text questions in the books. Let us discuss some of the activities given in the chapter. The first activity asks you to discuss whether the walls of your classroom are at rest or in motion. That is quite simple to tell. Indeed, all the walls in the entire world are in rest. They do not move. The second activity asks you to share your experience. If ever you have experienced that the train in which you are sitting appears to move while it is at rest, I believe it is a very common phenomenon. We all might have experienced it while traveling in a train. The third is about think and act, wherein they discuss about erratic and uncontrolled and controlled motion. Now, if I talk about erratic motion, as you can see in the image, when the water is unchecked, when the motion isn't in your hand, it is in control, it causes destruction, like during a flood, right? Now, if you could control the movement of water or the flow of water, build check dams, go for generating hydroelectricity, then the controlled motion of water can be of a lot of use to you. Like this image of a dam built on a river. So, a angle to motion could be controlled and uncontrolled motion also, as per given in the activities in the book. Now, moving forward, let us first recall a few concepts. The first concept that we will be discussing is physical quantity. Physical quantity is any quantity which can be measured, generally expressed as a combination of a magnitude and an unit. Magnitude is the numerical value with which we denote the physical quantity. For example, if I ask you the weight or the mass of your body and you tell me 50 kg, then 50 is the magnitude and kg will be the unit. Moving forward, we are also aware about scalar and vector quantities. Discussing them, scalar quantity is any physical quantity which only has magnitude, possibly a sign, and no other characteristics. For example, distance, speed, time, pressure, temperature, etc. They are generally described as an element of magnitude and a unit. On the other hand, vector quantity has both magnitude as well as a direction. For example, displacement, force, velocity, acceleration, etc. Now, since in vector quantity direction is involved, they become very important in the study of motion. Now, looking at the picture, if I tell you that a car is moving at 45 kilometers per hour, then 45 kilometers per hour is the speed of the car. We don't know in which direction the car is moving. Now, if I include the direction, if I say that the car is moving at 45 kilometers per hour in the east direction, then since east the direction is involved, it becomes the velocity of the car. So velocity becomes a vector quantity and speed becomes a scalar quantity. Okay. So now we will discuss motion of an object along a straight line, which is the simplest type of motion. Okay, so for this, we will consider the motion of an object which is moving along a straight path. To explain the entire concept, I'll take the image directly from the book. Here, O is the origin or the starting point. A, B, C are the position of the object at different instances, right? The object starts from its origin O, then moves through C, B and reaches A. After reaching A, it moves back and reaches to the final point, that is C. So the path of the object is O to A and then A to C. So C is the final destination. Fine. Now I'll take the similar image here also. What we have to do is to find the total path length covered by the object. Okay. For that, what we have to do? We have to take distance O to A and then A to C, which is 60 kilometers plus 35 kilometers. The total path covered by the object to reach its final position is 95 kilometers. है ना? The distance is a scalar quantity. We very well know कि कितना distance cover किया object ने अपनी final position पहुंचने के लिए. Now we will discuss a related topic which is displacement. Okay, displacement क्या होता है? Displacement is the shortest distance between the origin and the final position of the object. अब O को C पोजीशन पे पहुंचना था. Now C पोजीशन वो कैसे पहुंचा उससे फर्क नहीं पड़ रहा. C पोजीशन और O पोजीशन के बीच में शॉर्टेस्ट डिस्टेंस क्या है? उस डिस्टेंस को हम डिस्प्लेसमेंट कहते हैं, है ना? सो इस केस में O से C के बीच में व्हाट इज द शॉर्टेस्ट डिस्टेंस? इट इज 25 किलोमीटर. सो भले ही बॉडी ने 95 किलोमीटर डिस्टेंस कवर किया है, पर उसका एक्चुअल डिस्प्लेसमेंट कितना हुआ है? 25 kilometer. Okay, clear. So we can clearly distinguish between the term distance and the displacement of the body. Okay. Now when I use the term displacement, I mean the magnitude of displacement, है ना? The numerical value of displacement here. Now I am sure that you might be having a number of questions कि क्या displacement and distance एक से हो सकते हैं? क्या displacement zero हो सकता है? X, Y, Z. There might be multiple questions which I'll attempt to answer here. Okay. The first question that we'll discuss is कि can the magnitude of displacement be equal to the distance traveled by an object? कि क्या ऐसा हो सकता है कि displacement and distance of the object is same? Yes, of course, this can happen. But कैसे? Now suppose O is the origin and A is the final position, है ना? The body has to reach point A from here. So the distance that the body has to cover is from 0 to A is 60 kilometers, right? So in this case, what is the displacement now? Displacement be 60 kilometers over, right? So when the actual distance covered by the object and the shortest distance between the origin and the final position is same, then in that case displacement can be equal to distance of the body, right? But that has to be in a straight line. The object has to travel in a straight line in that case also. Now in this similar situation, if the final position of the object is B, मतलब object को O से A जाना है और A से B जाना है, in that case what would be the distance traveled by the object? It would be 60 plus 25, that is 85 kilometers, right? पर displacement क्या होगा? Displacement होगा O से B के बीच का distance, that is 35 kilometers. So in this scenario, distance or displacement same नहीं है, right? Moving further to the next question that you might have in mind, कि ऐसा हो सकता है क्या कि magnitude of displacement for a course of motion may be zero? Yes, ऐसा भी हो सकता है. And the fact is कि magnitude of displacement zero हो सकता है, पर corresponding distance covered zero नहीं होगा. ये सिनेरियो कब होगा? जब the origin of the object, that is O, point O, is the final position of the object. That is, when the object moves in a circular path, when the origin and the final position are the same, then in that case the displacement for the object would be zero. मतलब zero से start किया था, zero पे पहुंच गया, so the displacement क्या हुआ actually? कुछ भी नहीं. But since there is a course of motion involved, so distance covered would be 60 plus 60, that is 120, which is not equal to 0. So yes, magnitude of displacement for a course of motion may be 0, but the corresponding distance covered is not 0 if the object moves in a circular path. I hope I am making myself clear and you get the points that I have discussed here. Now what we will do it, here we'll quickly summarize what we have studied till now. So we have now distinguished between distance and displacement, one being scalar, displacement being a vector quantity. Displacement is the shortest distance and distance is the total path covered or by the object to move from initial to final position. Now with reference to distance and displacement, there are a few pointers that we need to remember. One is that displacement for an object could be 0, but the corresponding distance covered would not be 0, right? If the initial position coincides with the final position, in that case displacement would be 0, but the corresponding path covered would not be 0. Second is that the magnitude of displacement will always be less than or equal to the distance covered, but would not be more than the distance covered, है ना? क्योंकि it is the shortest distance between the initial and the final point, it can be equal to distance covered, but would never be greater than the distance covered. Now, since direction is involved with displacement, it could be negative at times, right? Now, the first point that we had discussed, that if actual path is equal to the shortest path, मतलब distance and displacement are equal, then the object has to be traveling in a straight line. And the distance and displacement should have same magnitude because object has not changed its direction, right? I'm sure we are clear with these pointers. Now, the gist of the entire distance and displacement thing that we have studied is that these both terms, these both physical quantities, which are two different quantities, are important to describe the overall motion of the object and to locate its final position with reference to its initial position at a given time. मतलब distance and displacement ये दोनों अलग quantities हैं और दोनों ही important होते हैं किसी भी object के motion को describe करने के लिए और उसकी position बताने के लिए with reference to its initial position at any particular given time. Okay, I hope I have made myself clear here, right? Okay, now so we'll take some in-text questions provided in the book. The first question is, an object has moved through a distance. Can it have zero displacement? If yes, support your answer with an example. So we have studied this scenario. We know that displacement can be zero if the initial and the final position coincide. Okay. The second question is that a farmer moves along the boundary of a square field of side 10 meter in 40 seconds. What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from its initial position? So here it involves certain calculations. I will tell you how to attempt for it. So this is a square field. I take A as the initial or the reference or the starting position of the farmer. He moves along this square field. Okay. So I know the sides is 10 meter. No, this is 10 meter, I know. And I also know that the farmer covers 10 meter in 40 seconds. But what will be the final position of the farmer? That I have to find out. So how much distance will the farmer cover at the end of 2 minutes 20 seconds from A? I'll have to find out. So for that, since he moves along the square boundary, I'll have to first find the perimeter of the square. I'll find the distance covered in 1 second because 40 seconds का दिया हुआ है. Then from these two things, I will find out the number of rotations the farmer had along the square field. That I'll find out by total distance divided by the perimeter. Now this will give me the final position at the end of 2 minutes 20 seconds, which I have calculated and is point C. Now the farmer has made around 3 rounds and reached point C. What would be the displacement? That is the shortest distance. How would I find that? I'll get the displacement by finding this distance AC. To calculate this, what I'll have to do is I'll have to apply Pythagoras theorem to find out what will be this distance, which is equal to the displacement, which is what the question asks for. Just to try it once, and if you have any queries, you can ask me. Okay, the third question is, which of the following is true for displacement? A, it cannot be 0. B, its magnitude is greater than the distance traveled by object. We have studied both of these questions in the previous slide itself. So yes, displacement can be 0, and no, magnitude of displacement cannot be greater than the distance traveled. Okay. Hope you are now clear with the concept of distance, displacement, all the relationships between them. We will now move forward. Okay, so now we will study two different types of motion, uniform and non-uniform motion. To understand the difference between both, we will study the following data points. Okay, now there are 3 columns given here. First one is of time. The second and third column shows you the distance traveled by 2 different objects within the given time interval. Now, if you analyze the data carefully, you will find that the time interval between 2 successive entries is 15 minutes. So, we are finding what distance object A covers in 15 minutes and object B covers in the same 15 minutes. When you study them carefully, you will find that the distance traveled by object A is quite uniform, right? That is, in every 15 minutes, the object A is traveling 10 meters, right? But this is not true for object B. See, between the first 2 entries, there is a difference of 7 meters and then 5 meters and then so. So, from the data we can infer that uniform motion is when an object covers equal distance in equal interval of time. So, the time is in equal interval of time, the distance traveled by object is also equal. Now, this is quite an ideal situation. Okay, so in general, when you talk about uniform motion, the time interval has to be smaller, right? And the path of the object in a uniform motion is a straight line. It is always a straight line. That is quite obvious because in equal interval of time, there is equal distance traveled. So if you represent it graphically, which we will learn in the further module, you will find that the graph would always be a straight line. Whereas for non-uniform motion, when an object covers unequal distance in equal interval of time. So the time interval is same as given in the data points, but the distance traveled by object B in the same time interval is different. So when an object covers unequal distances in equal interval of time, then the object is said to be in a non-uniform motion, right? Non-uniform motion is very common. All the type of motion mostly that we know are non-uniform in nature. Like a car moving on a crowded street, you know that you'll put on the brake, then you'll increase the speed, so that the motion there would be quite non-uniform. Okay. So now we have learned what motion is. We are aware of the terminologies related to motion. So we can easily determine if a body is in motion or not. Now moving further, we will study how to measure this motion. Okay. To do so, I would want you to just have a look at these 2 images. We will just discuss whatever is shown there. The first image seems quite familiar, I am sure. It is of a cricket match. the bowler bowls a ball to the batsman, right? When the bowler bowls the ball is set into motion. That is, the ball travels particular distance in particular time frame. And using these two data, the speed of the ball is calculated. Now we know that there are 6 balls per over, so the speed of all the 6 balls is mentioned here in the television set, right? Now moving to the second image, it is about a highway and there is a signboard in the highway wherein they have mentioned the speed limit, right? In both the images, we know we are talking about a common term, that is speed. So now we'll discuss what speed is. Now before discussing the same, suppose in the same highway as mentioned here, you are traveling along with a truck. The truck may be loaded or may be overloaded too. That is the case most of the time. So you know that the truck, the speed of the truck and the speed of your car may be same, they may be different. Your car and the truck might cover the same distance in different time intervals. That is quite obvious, right? So both the vehicles can move at the same rate, can move at different rate, can take different amount of time to cover a given distance. That is quite a known fact. Okay. So one of the way of measuring the rate of motion is to find out distance traveled by the object in a particular unit of time. Now this distance traveled by object in unit of time is termed as speed of the object. Okay. Now speed is also a scalar quantity. We need only to specify its magnitude. There is no direction involved in defining speed. And also that speed need not be constant. It can be varying in nature. And obviously it is varying in nature. Now I want you to go back to this particular image here. As we all know, there are 6 balls in an over, and all the 6 balls bowled by the bowler are of different speed. It is very unlikely that the bowler bowls 2 or 3 balls with the same speed, right? So a single bowler can bowl all the 6 balls at varying speeds. So how do you find the average? How do you find the average? You need to find an average. Now you cannot report that the bowler bowls at this speed, this ball at this speed, then the next ball in this speed. That is not quite unlikely. So what you do is you find average speed. Now since mostly all the objects will be in non-uniform motion, therefore there is a need to describe the rate of motion in terms of average speed. What you do? You find a average speed. Now how do you find this average speed is what we'll study. Now you find average of anything by finding the mean, right? So to find average speed of the object, what you'll have to do is to find the total distance traveled by total time taken, right? You sum up all the distance traveled and divide by the sum of the total time traveled, time taken. So we find a standard formula for average speed here. If we say that the distance traveled s by an object in time t, then the speed of the object v, small v, we denote speed with small v, is distance traveled by time. S is equals to distance by time. That is what you have been studying, right? So speed is distance by time. Now the standard unit of speed is meter per second, right? And there are other units too. You can denote speed in kilometers per hour, kilometers for distance, and hour for time, or centimeters per second. So these are the various units in which you can denote speed, but the standard unit is meter per second. Okay. Now we'll discuss further about velocity. Okay. Velocity, as we have discussed earlier also, is nothing but speed with direction. Now, if you can define speed in terms of distance and time, you can define velocity in terms of displacement by time. It is quite same to what speed is. It is just with added direction to it. Now, velocity can be uniform and it can be variable also. Now, to change the velocity of an object, you can either change the speed of the object or you could change the direction of the object, or you could change both the speed and the direction of the object. Now, when your object is moving along a straight line at variable speed, then we can express the magnitude of its rate of motion in terms of average velocity, right? Because the speed is variable, we have to express it in terms of average velocity, right? Now, average speed and average velocity are calculated in the same way, and the units of both of them are also same. Now, there is one important pointer to note is that the magnitude of average velocity and the average speed of the object can be equal only in one condition, and the condition is that when the object moves along in a straight line. Now, in case velocity is changing at uniform rate, now this is quite an ideal scenario. We take this velocity is changing at a uniform rate, then you can find the average velocity by taking sum of initial and final velocity or finding the mean of initial and final velocity. So mathematically, if you say, then the formula would be velocity would be initial velocity u plus final velocity v divided by 2. So wherein VAV, we denote average velocity by VAV. This u is the initial velocity, v is the final velocity, and you take the mean of it, right? So what is the formula of average velocity? It is u plus v divided by 2. Now this is quite an unrelated thing that I'm going to tell you further, but this is also one of the activity that is provided in the book. Now what is an odometer? An odometer of it is an automobile instrument that is used to measure the distance covered by the vehicle or any automobile for the matter of fact. Now there is another question that is mentioned in the book, which is a numerical, and I'll quickly go through it so that you know how to solve the questions related to these. The questions say that during an experiment, a signal from a spaceship reached the ground station in 5 minutes. So what is the time? 5 minutes. What was the distance of the spaceship from the ground station? What we need to find is distance. The signal travels at the speed of light, that is 3 into 100 meters per second, that is mentioned here. So you need always, when you attempt a numerical, it is very important that you read it thoroughly twice or thrice until you understand what the numerical asks for. Always write down whatever data points are mentioned in the question and then go to solve it. Okay, so here the speed is given, time is given. Now since time is given in minutes, we'll convert it in second because we are given the speed of light in meter per second. Okay, so we need to find the distance. If speed is equals to distance by time, then quite obviously distance is speed into time. So we'll quickly multiply speed with time and we'll get the distance in meters. So and always remember, whatever is the unit given in the question paper, until unless mentioned otherwise, you should always find the answer in the required unit only. The next concept that we'll be discussing is acceleration. Acceleration is nothing but rate of change of velocity. Now, if the motion is uniform along a straight line, then obviously there is no change in velocity. The velocity is constant. So rate of change the change in velocity is 0 here. But if the motion is non-uniform, that is obviously the velocity is varying with time and the change in velocity is not 0. Now acceleration is basically change in velocity of an object per unit time. The kind of motion then is called accelerated motion. Acceleration, like velocity, is a vector quantity. Direction is involved. And so there could be two types of acceleration. Positive acceleration is said to be when the direction of acceleration is in the direction of velocity. Negative acceleration is when it is opposite in direction to that of direction of velocity. Now, if we have to find a standard formula for the same, then we can say that acceleration is change in velocity per unit time. or by time taken. So changing it into standard terms, acceleration is denoted by small a. Initial velocity is u and final velocity is v. So how do you find change in velocity? By subtracting initial velocity from final velocity. So v minus u divided by t, that is the that is the formula for acceleration. The unit of acceleration is meter per second square. Now, there are two types of acceleration: uniform acceleration and non-uniform acceleration, based on the type of motion that we are discussing. So for a uniform acceleration, if the object travels in a straight line and its velocity increases or decreases by equal amounts in equal interval of time, then the object is said to be uniformly accelerated. This is quite an ideal scenario. This is possible when a body is freely falling. Okay. Now, if the motion is non-uniform, that is the velocity of the object changes at a non-uniform rate, then the acceleration is called non-uniform acceleration. Right? The examples could be a car traveling on the road. The speed is increased or decreased by unequal amounts in equal interval of time. In that case, you say that the motion is non-accelerated acceleration. Okay? Okay, so now we will discuss some in-text questions. Question number one is, when will you say a body is in uniform acceleration and non-uniform acceleration? This we just discussed, so you can answer that very easily. The second is a numerical, which says a bus decreases its speed from 80 kilometers to 60 kilometers per hour in 5 seconds. So initial and final velocity both are mentioned, and the time is also mentioned. What you need to do is find the acceleration of the bus. So I have taken the initial velocity, final velocity, and time taken, and calculated the average by the formula that we had just discussed. I'll give you a small tip. You can quickly convert kilometer per hour to meter per second by multiplying it by 5 by 18. It is nothing but just a conversion fraction that comes after dividing it. Similar to this is the third question, which says a train starting from a railway station and moving with uniform acceleration attains a speed of 40 kilometers in 10 minutes. Find its acceleration. So, since there is no initial mentioned what is the initial speed of the train, so we consider it to be 0, of course, because it is starting from the railway station, so it is 0. Then the final speed is mentioned. We'll convert it into meter per second. The time is given, we'll convert into second, and then we'll find the acceleration by the formula mentioned. So these are quite simple questions. I know, of course, the problems given after the chapter are not as simple as these. We'll discuss them also if required. We'll move further and discuss uniform circular motion. To understand uniform circular motion, I would first want you to imagine a rectangular racing track, and suppose you are the athlete who is running on the track. You have to complete a round. Now, if you have to complete a round of a rectangular track, you start from a point, you move to the edge of the rectangular track, and then you have to change the direction. Then you move forward, you come to another side of the rectangle, you have to then change the position and proceed further. So if you are running on a rectangular track, you need to change your position 4 times to move further. Similarly, if you start increasing the number of sides of the track, from a rectangle you go to a pentagon, you have to change your direction 5 times. Then you move further, a hexagon, a septagon, octagon, and like that. So when you keep on increasing the size to a point that the track becomes circular, you will understand that in a circular track you need to change your direction of motion every time, at approximately every small interval of time you are changing the direction, or you are changing your direction. So what is uniform circular motion? Uniform circular motion is when an object moves in a circular path with uniform speed. Now, the only change in velocity along circular path happens due to change in the direction of motion. When you talk about uniform circular motion, the motion has to be in uniform speed along a circular path. So the only change in velocity happens because you are changing the direction of the motion, right? Now, as we have discussed the example of the athlete moving on a circular path, he or she has to change the direction at every point in time. So if you are considering a circular field, we can find the circumference of a circle. If the radius is r, then it would be 2r. Now, if an athlete takes t seconds to go once round the circular path of radius r, the velocity v can be given by the circumference of the circle or field divided by time. So what is the velocity in case of uniform circular motion? It is 2r divided by t. Now there is an activity which is mentioned in the book which says take a piece of thread and tie a small piece of stone at one of its ends. Move this stone and describe a circular path with constant speed by holding the thread at the other end, shown in the figure. Now, if you do this activity, you can also try doing this activity. Now, what you have to do is now let the stone go by releasing the thread. Can you tell the direction in which the stone moves after it is released? And by repeating the activity for few times and releasing the stone at different positions of circular path, check whether the direction in which the stone moves remains the same or not. Now, if you do this activity, what you will find that whenever you release the stone, at whatever point you release the stone moves in tangential in the tangent as a tangent to the circular path. Because once the stone is released, it continues to move along the direction it has been moving at that instant. Now, this shows that the direction of motion changes at every point along the circular path, as we were discussing in the example of the field that we were discussing about. Okay. Now, what can be the example of uniform circular motion? Then the examples could be the motion of moon and the earth. They are quite uniform. They are quite fixed. They happen as they happen. A satellite, which is a circular orbit made that is revolving around the earth, or a circular track made cyclist cycling at a constant speed. All of these are the example of uniform circular motion. Okay. Now here we end our module number 1, in which we have discussed the 5 major topics that I had told you in the starting. We'll just quickly summarize. We have learned that motion is change in position with time. It could be described in terms of distance moved or displacement. Motion could be uniform, non-uniform, depending on whether its velocity is changing or it is not changing. Speed is distance by time, velocity is distance by displacement by time. Acceleration is change in velocity by time. And if an object moves in circular path with uniform speed, the motion is called uniform circular motion. This is all what we have learned in our module 1. We will discuss about the graphical representation of motion and equations of motion in our next module, which I'll be uploading shortly after this video. Thank you so much for watching this video. I hope I could help you in understanding the concepts well. Please do like the video if I could help. If you have any doubts or you have a feedback, please do comment below. You can also write to me at learningsutras@gmail.com. If you want the notes and solution to the questions, do email me or comment here. I'll try to reply to everybody if possible. Also, to subscribe to the channel for the upcoming chapters. I plan to cover various topics in the future. Do let me know if you want me to take up any particular topic. I will be happy to come up with the content as soon as possible. Until then, stay safe, be positive, take care, keep smiling. We'll catch up soon. Good day. Bye-bye.